The compressor is the heart of an entire AC system, and it's the most important and expensive part, and is the most susceptible to damage by other faulty system elements. What to pay attention to while installing a compressor? How was the previously installed compressor damaged? How to avoid costly damage? Don't worry. Nissens experts are here for you. The compressor's main task is to pressurize and circulate the coolant in the system. Because of the refrigerant state transition it provokes, we can enjoy cool temperatures inside our car. In this Mazda, I'll remove the old seized compressor and install a new one. But how to do it? It's simple enough. Each of our boxes has a QR code, and you can scan it to download a detailed installation manual. Today, I will tell you the essential things you must remember while replacing the compressor. Let me get to it. First, diagnostics. I have to determine what caused damage to the compressor because it's pretty durable if installed within an otherwise functioning system. How do we check if our compressor works fine? Let's begin with pressure control. The static pressure will tell us if there is enough refrigerant in the system, and if the reading is below 2.5 bar, most compressors won't start. The next stage of diagnostics is efficiency. We need to check if the system can generate and supply cool air to the cockpit. The working pressure test will tell us if the system is unobstructed and if the compressor generates the desired pressures. The auditory compressor control can tell us if the damage occurred inside the compressor or to the power transmission component. Visual control is crucial and should always be part of diagnostics. The sight glass inspection will tell us if the internal state of the loop is in good shape, and it will also show us the condition of the refrigerant and the lubricant. Remember, troubleshooting is vital. The compressor can often break down due to the other faulty elements in the AC system, and their root causes should always be found and eliminated. You can learn more at our Nissens Experts website. Flushing is another critical step that must always precede the compressor replacement. It is vital to mention that warranty conditions for most leading compressor manufacturers require it. It is crucial to flush the system, especially when the previous compressor broke down due to a seizure or complete burst. A correctly performed flushing eliminates all impurities remaining in the system and allows for draining all oil, thus facilitating proper charge. To learn more about the recommended flushing methods, visit our website. There you can download a poster that can be helpful in any AC workshop. Find the poster and more at our Nissens Experts website. The condenser's state evaluation is an essential step in diagnostics. Soiling spotted on its surface or deteriorated parts like bottom fins may quickly worsen the condenser's thermal performance. Furthermore, these will promptly expose the AC compressor to excessive load, shortening its longevity. Any traces of leaks like oil residues are also a sign for the technician that the system may be leaky, thus losing the refrigerant and the oil lubricating all moving parts. Remember that all repairs requiring component replacement would require the AC system evacuation beforehand. This system runs on R1234YF, so I must choose the correct service station and suitable hose couplings. I evacuated the coolant and the system is currently empty, so I can now replace the damaged compressor. All connections within the AC system need to undergo a thorough visual inspection. Any traces of oil or leaks are naturally a potential source of the coolant loss and impaired AC compressor lubrication. Overload, overheating, and burnout are the most common compressor failures. The lubricant plays a key role here. Wrong type or improper volume, UV contrast overdosing, or a leak stop agent application will all degrade the oil's lubricative capabilities and lead to severe compressor failures. Seeing burned oil like this via the sight glass, you can be sure the piston and the cylinder generate abnormal frictions and seize. If that is the case, the compressor must be replaced, and before this, the entire system must undergo a thorough flushing. If the oil overheats, tiny particles of carbonized oil start forming and blocking the narrow channels of the control valve, TXV valve, or the condenser tubes, leading consequently to a severe AC system failure. Another common problem is the compressor's control valve malfunction and the compressor's clutch failure. The driving belt tensioner failures and the belt's vibrations will destroy the compressor's clutch, so this needs to be tested for and eliminated. If refrigerant leaks are spotted on the compressor housing or anywhere within the loop, dedicated diagnostics should be performed. All leaks must be repaired, as refrigerant losses lead to insufficient compressor lubrication and moisture intrusion. Besides, the low charge exposes the compressor to an excessive load, leading to its premature failure. You can learn more about compressor diagnostics via Nissens online courses and at Nissens Experts website. The surface of this condenser is rather dirty, adversely affecting its thermal performance. It looks okay from the backside, but every time the lubricant overheated and the compressor was seized, a new condenser must be installed. Because of the very thin microtubes, it cannot effectively be flushed. That's not all. Much like the expansion valve, we also need to install a new cabin air filter, equipment drive belt, and receiver dryer filter, unless you bought a Nissens condenser, which comes with the dryer filter integrated. Moreover, all Nissens condensers are powder-coated, guaranteeing supreme corrosion protection, thus the part's longevity. I'm going to install just such a condenser. Another stage is to prepare the compressor for installation in the vehicle. Manufacturers like Nissens pre-fill new compressors with oil, but as a technician, I need to control the amount and oil type defined for the system. In the case of this Mazda here, it is PAG-YF, so I unscrew the ports and drain the oil. In this Mazda, I flushed the entire AC loop, so no oil remains there. Now, I need to add an appropriate amount to the compressor. If you're not sure how much oil is enough for your system, don't worry. The Nissens Experts website has the right tool, an oil and gas finder with the type and quantities for most car models. When it comes to oil, you should only use the car's or compressor's manufacturer prescribed oil. The universal ones don't work. I know it from experience. I need 100 milliliters of oil for this Mazda, the same amount I drained from the compressor. If there is less than that, you obviously need to add the missing amount of the PAG-YF oil, and the next step is to fill it. Now, after filling the compressor, I need to turn the compressor shaft minimum of 10 times so that the oil is spread evenly throughout all the inner parts of the component. Now it is ready to be installed. Remember to keep the plugs that came with the compressor during the mounting process, as they prevent impurities from getting inside the part. New O-rings also came with the set, which must be lubed with oil before the installation. The compressor's electric connections and harness should also be inspected for insulation breaks, plug damages, moisture, and impurities in couplings. Remember to check the electric fans. Mazda is screwed back together, and a tightness test has been running since yesterday. I filled the system with nitrogen laced with hydrogen so that my detector could find leaks easily. I am also watching the gauge to see if any pressure decreases. If there is any, it's a good time to fix the system now. Remember, before you fill the system, you must be sure that the system is completely tight. That's why we recommend the pressure test be no shorter than 12 hours, with at least a 10-bar charge. A long-term vacuum is necessary for drying and removal of any traces of moisture from the system. Run by the diagnostic station examines the tightness once again, but also the vacuum makes it easier to fill the system with refrigerant afterward. The recommended vacuum time is 60 minutes for the ambient temperature of 21 degrees Celsius. Installation of an AC compressor is an advanced and demanding procedure, but if you do it right, the newly installed part will serve perfectly for years. We share our expert knowledge with you, but do you have some insights? Could you share it with us? The authors of the best tips will be rewarded with professional testo equipment, like the one I use myself. Let me also invite you to our Nissens Experts platform.